Hello everyone. Today I shall discuss exercise 14.3 question number 2. Draw wherever possible a rough sketch of a triangle with both line and rotational symmetries of order more than 1. Right? Let us draw a triangle. That is, the triangle should be a equilateral triangle. Let us draw an equilateral triangle. This is an equilateral triangle, and if we draw the we draw the line symmetry, we are getting 3 line symmetry. Here you see, we are getting 3 line symmetry, that is this one is one line symmetry, this one, that is one line symmetry, right? And this one is another line symmetry, this one is another line symmetry, and if we draw another line symmetry, that is this one, right? This one is another line symmetry, that is we are getting 3 lines of symmetry for this triangle. If we take another triangle like this, and it has rotational symmetry of order 3, that is more than 1. How? You see, if we write here this as A, if we rotate this one, this A will come at this A, at this point, with A dash, and if we rotate again, the A dash will come at this point, A double dash, right? That means if we rotate this one, it will be 120 degree. It will be 120 degree. This is 120. This is 120, and this is 120 degree. That means if we rotate this one, this A will come at A dash, and again if we rotate this one, this A dash will come A double dash. That means, and right, and if we rotate once again, that this will come at this, right? That means there are order of symmetries 3, order of symmetry, order of symmetry, order of symmetry, order of symmetry is 3, right? Therefore we can say that a triangle with both line and rotational symmetries of order more than 1, there is an equilateral triangle, that is number 1 is an equilateral triangle, a equilateral triangle, equilateral triangle have both line and symmetrical order and symmetries of order more than 1, that is order of symmetry is 3, right? And lines of symmetry is also 3 for an equilateral triangle. Now question number 2. Question number 2 is if I draw a triangle, this is an equilateral triangle. Next we'll draw another triangle, that is this one. this triangle, right? Another triangle, right? If we draw another triangle, if I draw an isosceles triangle, that is both the sides are same, right? That means if I draw an isosceles triangle, that is this one, right? That means if we take ABC, if we take this is A, this is B, and this is C. AB side is equal to AC side, right? This triangle has a line symmetry, only one line symmetry, this line symmetry. Line of symmetry is this one only. This is the line symmetry, right? One line symmetry and no rotational symmetry. See, here we are getting no rotational symmetry. If we turn this one, this A will come here, but we will not get any rotational symmetry. Therefore, question number 2 is an isosceles triangle, an isosceles triangle, isosceles triangle, isosceles triangle have only one line symmetry, have only one line symmetry, only one line symmetry, only one line symmetry, only one line symmetry, and no rotational symmetry, and no rotational symmetry, no rotational symmetry, no rotational symmetry of order more than 1, no rotational symmetry, double aim, no rotational symmetry of order more than 1, more than 1. That means if we rotate this one, right, when it comes again 180 degree, then it comes in this position, and that is order is only 1. Here in this case, order of symmetry is a 1. Order of symmetry is 1 only. Order of symmetry is 1 for isosceles triangle. For isosceles triangle, right? Now solve question number 3. Question number 3 here you see is question number 3 is here you see question number 3 is 1 to 3. A quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. You have to draw a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. For that, you will draw a parallelogram, right? If we draw a parallelogram, if we draw this parallelogram, this one, this parallelogram, right? It is a parallelogram, and if you write the name here, A, this is B, this is C, and this is D, right? A parallelogram has no line of symmetry. You see here, if you draw it this way or diagonally or this one, we will not get any line of symmetry in case of parallelogram, right? That means a parallelogram is a quadrilateral which has no line of symmetry but a rotational symmetry of order. Rotational symmetry, you will find the rotational symmetry here in this case. Suppose this one, this C, right? This C will come right here. You see a quadrilateral with rotational symmetry of order more than 1, right? Here you see, if we take another 2, Suppose this one is 1, this one. Let us take another 2 parallelogram. Let us take this one, that is take cloning 1 and 2, right? Now here you see, if we put a number, that is a point, if I taking, right, this point, suppose this is a point I am taking at this point, this is the arrow. If we rotate this one, it will come here, right? If we rotate again, it will come here, right? When the point comes here, then we get first position, right? This is when we rotate this one. This is, suppose this is the point, this is the point. If we rotate once, this point will come here, but we are not getting the symmetrical, right? When, if we take this, let us take another example. For example, we are taking this one. For example, we are taking, let us take another parallelogram to understand better way, right? Let us take another parallelogram to understand in a better way, right? Question number 3. Let us take question number 3 again. Let us see a quadrilateral. Question number 3. Let us take a parallelogram. Let us take a parallelogram, this one, and if we increase this length, right, and if we clone it, drag cloning, one is here and another is here, right? If we name it, the name is ABCD. The name here is ABCDA. This is B. This is C. This is D. Right? Question number 3. A quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. We are not getting any line symmetry, right? Here in this case parallelogram. And if we take rotational symmetry, suppose this is the point. This point I have taken, this one. This point I have taken here. If you rotate this one, it will come in this way, that it will get the shape like this, and this point will come here, but we are not getting rotational symmetry. Again, if we rotate, then this point will come here, right? That means there are two positions, this position, this position, and this position. That means two on this position and this position is rotational symmetry. Once again, you see, if I take the point as here, if I rotate in, it will come here, and again if you rotate, then it will come here, right? Again if you rotate, it will come here, and again if you rotate, it will come here. That means in two positions we'll get the rotational symmetry. The rotational symmetry, order of symmetry is 2. Order of symmetry is 2 here. Order of symmetry is 2. Then we got a quadrilateral, that is a parallelogram has a rotational symmetry, has a rotational symmetry of order, rotational symmetry of order 2, but not a line symmetry, not a line symmetry, right? Dear friends, now we'll see solve question number 4. Question number 4 is a quadrilateral with line symmetry but not a rotational symmetry of order more than 1. Right? In question number 4, if we draw a kite, let us question number 4. Question number 4 is this one. If we rub this one, you will get question number 4. Question number 4 is, here you see this is question number 4. If I draw a kite is like this. Kite is like this. Kite is like this. And we name it, that is A, B, C, D. Right? Equivalent with a line symmetry. Here it is a quadrilateral and it has a line symmetry. See, this one is a line symmetry in this way, right? Line symmetry, but not a rotational symmetry of order more than 1. And if we rotate 4 times, it comes again in this position. That is, it is order rotational symmetry of order not more than 1. Therefore, it is a kite. A kite is a quadrilateral. A kite is a quadrilateral. A quadrilateral. A kite is a quadrilateral with a line symmetry line symmetry but not a rotational symmetry, not a rotational symmetry of order more than 1. Right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.